material that's in its orbit compared to Earth or Jupiter or one of the other regular planets. But I guess the way I look at it is every time Ceres encounters another body in its orbit, it's going to win. So if you came back a billion years from now, theoretically Ceres would have cleared much more of its orbit. So the question would be, at what point do you say not a planet and then it's a planet based on that criteria?
Right, and you have to be careful here because Ceres won't necessarily win. If there are enough interactions with smaller objects, you can actually create a situation where Ceres would migrate in or out from its current orbit.
Oh, right.
And it could get tossed right out of the solar system by Jupiter or dropped into the sun or something like that. That takes a long time. We're talking evolution on a scale of hundreds of millions or billions of years.
Right.
But as Alan Stern told me, and I love this when he said this, you can imagine a scene in the original Star Trek where they go into a solar system and Spock says, we have an object of planetary mass ahead. And Kirk says, is it a planet? And Spock says, well, we're going to need 6 weeks to survey the entire solar system to let you know that or not. That's a little unsatisfying. And it's kind of funny because an object the size of Earth, if it were orbiting out, and not too far from where Pluto is now, by this current definition, it wouldn't be a planet. Because it still wouldn't be big enough to sweep out all the material out there because space is vast. And so there's just a lot of junk floating out there. And even over the lifetime of the solar system, an object the size of Earth wouldn't be able to clean out its region. So it's, I can tell what happened here. The IAU people who made this decision were looking for a reason to not make Pluto a planet. And that's the problem, is that you come into this with a bias. Do you want Pluto to be a planet or not? That's going to affect your decision making. And if you make Pluto a planet, well, then Ceres becomes a planet, and Pallas, another asteroid, I believe, becomes a planet. Mm-hmm. And then you've got these other things, Quaoar and Sedna and Eris and all these other objects out there past Pluto. How many planets does the solar system have? It's either 8 or it's possibly millions.
Right.
And so this whole thing is a mess, and in my opinion, it all comes down to the point that you are trying to draw a line in the sand that maybe doesn't necessarily need to be a line. It needs to be a big fuzzy thing. Mm-hmm. And all you do is make people angry no matter what you do. So, I don't think Pluto really cares what we call it. I think it just is what it is, and we should just go and study it.
That kind of leads us right into your book, Death from the Skies, where you're talking about different objects being knocked out of their orbits and falling into the sun. But, of course, one of the things that can happen is one of them can fall into us. And that's included in your book. I saw your presentation at DragonCon about the book. What a great presentation, by the way. It was educational. Yeah, very educational, yet I think we laughed for half of it because you're such a great presenter. So tell us a bit about your book for our audience.
Well, of course, I agree with you. I'm not going to argue your point. So the book is about all the ways I could think of where astronomical events could wipe out life on Earth. And these were really fairly practical. I've had some people come up to me and say, what about this? What about that? What about colliding with an antimatter Earth? And I thought, well, yeah, but, even on the scale of unlikeliness of some of the realistic events, that one's pretty unlikely. There's, not a bunch of antimatter planets roaming around the universe. But I sort of ordered them from near to far and most likely to least likely. And so chapter 1 is asteroid and comet impacts. And right now, we don't know of any large asteroids that are going to come down and smack into the Earth and wipe out all life on Earth. But that doesn't mean that we aren't going to have that happen in 100 years or even in 5 or 10 years, something large enough to put the hurt on us. So I talk a lot about what asteroids are, how they're dangerous, because these impacts really are dangerous. They wiped out the dinosaurs, most likely. We're pretty sure there were other extinction-level events caused by this sort of thing. And we know that asteroid impacts, there was one that blew up over Tunguska, Siberia in 1908, and we know that if that happened over, say, New York City or London or something like that these days, it would kill millions of people. So this is a serious thing, and we now have the technology to prevent it. You don't really want to lob nuclear weapons at this thing, but you can send probes which can sort of hover off the edge of the asteroid. And let me tell you how much I loved this idea when I first heard it. You don't have to land on it. You don't have to blow it up. You don't have to mount a rocket upside down to push it out of the way or anything like that. You actually park your probe a few hundred yards off the surface of the asteroid and then use rockets to gently use the gravity of the probe itself to tug the asteroid into a safe orbit. And it's called a gravity tug or a virtual tether. It's not actually connected physically to the rock. It's just gravity. And it turns out this will work. You can do this. It's not science. Well, at the moment it's science fiction, but in 5 years it'll be science fact. We'll be able to do this. And that's just totally cool. And so the rest of the book is basically, every kind of disaster I could think of. Solar flares, a black hole passing through the solar system, a nearby supernova, the end of the universe, and yes, even aliens invading. I see a lot of people speculating about aliens, and certainly movies talk about this, aliens coming down and stealing our water and mating with our women and, all this ridiculous stuff. It's women, all this nonsense. And that's not how I envision an alien intelligence really wanting to destroy the Earth if they so desired. And so that was the one chapter that really kind of creeped me out writing it, because it seemed like an awfully likely scenario.
Oh, sure. One of the things you said during your presentation that I actually didn't really understand, so I'm going to take this opportunity to ask you. You were comparing the movies where the asteroids hit the Earth and how crazy they were, weather on the planet or weather on the asteroid and rain and stuff in Bruce Willis's movie. But then you said that I think it was in Deep Impact that when they exploded the asteroid and it turned into smaller pieces and they burned up in the atmosphere, you said that actually wouldn't work either because the mass was still the same, and I didn't quite understand that.
Well, basically, at the end of Deep Impact, and spoiler warnings for those of you out there who haven't seen this 10-year-old movie now. And let me tell you something. This is a great movie. I just watched it again literally a couple of weeks ago with my daughter, and it was just as good as I remembered it. It was a good flick.
Yeah, it is.
At the end of the movie, they blow up this comet right before it hits. And so they took this giant comet that was like 5 miles across and turned it into billions of tiny little rocks that then impacted the Earth. And no, the thing is, the reason impacts are dangerous is because of energy. You're taking all the energy of motion of this enormous object and you're converting it basically into heat. And so it's hitting the Earth, it's creating a tsunami, it's a shock wave, it turns into heat, which then propels megatons of rock up into the atmosphere and then back down to burn up all across the planet. And so the energy of impact depends on how fast the object is moving and its mass. So if you blow a comet up and all the mass still hits and it's still hitting at the same speed, you have not changed the impact energy at all. All you have done is you've converted one big impact into a trillion littler impacts. And so in some cases that might be worse because you're spreading the disaster around. But at the very least, you're not making things any better. You're still basically dumping enough heat into the Earth's atmosphere to basically flip an oven switch onto roast or broil. I don't think roast is a word, but it should be. Just now, because I've got my heat up here. And so you're not helping any. You're basically destroying the planet either way. And so the better thing to do, the realistic thing to do, is to not make the thing hit. That's all you really care about. So that means either pushing it out of the way or blowing it up so much earlier than impact that the pieces sort of expand and you only get a little tiny bit of them hitting. So you just get like a little bit of a meteor shower rather than, quintillions of tons of rock coming down and slamming into the Earth or whatever it would be.
Yeah, I guess it's sort of analogous to being shot with a high-powered rifle versus getting shot with a shotgun. Neither one is very pleasant.
Feet away, you're screwed. Now, if you shoot a shotgun from 100 yards away, right? Yeah, the odds of getting hit are basically zero. So that's what you want to do, blow it up earlier. Or, instead of getting shot by a shotgun, have somebody tap you on the forehead 52 bazillion times, right? An extremely low energy event a lot of times isn't a big deal either, but if it's spread out over time. But these analogies maybe aren't so good.
Right.
That one maybe sucks a little. But in the end, the best thing to do is to keep it from hitting in the first place.
Mm-hmm. Now, you recently